Hi, we are Team Backprop to the Future, and today we will be reviewing some of our key design decisions and then reflecting on the project and our teamwork as a whole. Our first key design decision was our choice of model. So we had two main models that we were deciding in between. First, we had collaborative filtering, where users have their ratings predicted based on some similarity with other users. Collaborative filtering works well with dense matrices, does not require any training, and has slow inference, but it uses real-time data during inference. Finally, it loads all relevant data into memory when making predictions. On the other hand, matrix factorization has their ratings predicted by product of decomposed matrices. Matrix factorization works well with sparse matrices. It requires some training time, but inference is extremely fast. However, inference only uses the data that was used during training. Finally, matrix factorization only needs to load low-rank decomposed matrices into memory instead of all the data. Ultimately, we decided to go for matrix factorization for three key reasons. First, the ratings data is actually extremely sparse because the vast majority of movies are not watched by the vast majority of users. Second, in our system, fast inference speed was extremely crucial, which could be achieved with matrix factorization. And finally, the main drawback of training taking time is not a big issue because training can periodically be done asynchronously so that it doesn't interfere with our inference system.
So our second design decision was to use a database. So initially we were using static files in the form of CSV and JSON, and we switched over to database due to certain advantages that it gives. So firstly, database can handle large volumes of data efficiently with the help of indexing. And in case of static files, these files need to be loaded into memory each time. And as the size of the data grows, it gave us memory out of memory problem. And secondly, a database enforces a schema, whereas static files do not have any schema validation. This could lead to data inconsistencies later on. Databases support complex querying without additional implementation, while static files require custom implementation for even basic functions like searching. The biggest advantage is that a database supports concurrent accesses like read and writes, while static files do not support concurrent writes. So the final decision was to use a PostgreSQL database. So that we chose SQL because the team has existing knowledge in SQL, which allows for faster implementation and it makes troubleshooting easier. Secondly, we chose PostgreSQL because it has a lightweight setup while maintaining all the robust database features. Finally, we decided that using a database provides a better foundation for handling increased data volumes as our recommendation system grows.
Design choice which we were forced to make was whether to use Kubernetes or not. There's several pros and cons of Kubernetes, especially in our case. The pros are the whole purpose of using Kubernetes itself, which mean they scale really well across multiple services and nodes. They support routing updates, auto scaling, and self healing, and they integrate really well with CI/CD and monitoring tools like Jenkins and Prometheus. Kubernetes are the industry standard for large production-grade distributed systems, and they also work well with microservices architecture. However, there are some downsides to using Kubernetes as well. The first of them being Kubernetes is not easy to learn. It has a very steep learning curve and adds a lot of configuration overhead. There is too much complexity involved for a system with limited deployment needs, which was in our case, since this was a course project. Kubernetes also leads to debugging failures and it slows development significantly. We also need persistent storage, shared database setup, and networking, which made things pretty complicated for us. So finally, we decided not to use Kubernetes. While Kubernetes is really powerful, it did not align with the needs of a specific use case and time constraint. The trade-off for learning curve was not worth it when a simple load balancer was sufficient at the time when we were designing our recommendation system.
Project reflection. We had four parts as part of our project reflection: good coding practices, our early start with integrating tools, configuring the Jenkins pipeline, and finally reflecting on the models that we used. In terms of good coding practices, we had a modular code base and a comprehensive documentation to support it. We had used separation of logic, and we broke down our code into single purpose functions and classes so that we could debug any issues. We had also set up a robust README file with all the usage guides, and this would help to easily understand the instructions of how to use our code. In terms of early start and configuring Jenkins, we had used Jenkins straight from M1. We had our Postgre SQL server set up from M2, and same went with Jenkins. So these early use of tools helped us simplify our deployment process and avoid any kind of late stage refactoring that could have happened. And finally, we'd like to discuss about model enhancements. So we could have used better models. We could have used models like neural collaborative filtering or light FM, which can capture more complex user item relationships and deliver better recommendations. We could have also used hybrid approaches by combining collaborative filtering with metadata. This would incorporate many features of the movies like genre cast and would improve the recommendations for new users or lesser rated films.
Most of our team meetings were held in person, and we organized the meetings a week ahead of the deadline. We would brainstorm, whiteboard, coffee, and repeat. And we would discuss the problem at hand. We would create the flow charts. We would divide the work. And once we have discussed the ideas together, we would do the implementation individually and come back to do the documentation. We collaborated using Git. All our development happened on GitHub. We created different feature branches for all the features. And once individual teammates were done developing the features, the teammates would raise a pull request with all the feature notes, as you can see. Reflecting on what went well, the overall collaboration and understanding was spot on. People committed to attend meetings in person. We followed good practices like feature branches, PR reviews. Work and time commitments were always on time. The work was completed always on time and with the desired requirements. Reflecting on some of the challenges, there are sometimes lack of mutual agreement on design choices, like whether to go for SQL database or not, or the strategy for load balancing, or the metric to choose for recommender system. We had sometimes disagreement on these things, and sometimes there was lack of thorough testing on local, and the code was pushed to GitHub, due to which we had some conflicts. And sometimes before developing the new branch, a new feature branch, the updated code wasn't pulled from Git, and that created some problems. Challenges and lessons for the future. Good practices are must. Code reviews, PR reviews, raising PRs, creating feature branches. These are a must. And also, it's important to document every component and every design choice in the future.